So maybe we can start.
Yes, good afternoon. Thanks, Kapil. Yes, we can start.
Okay. So today we'll organize a small training where we will try to explain the basic architecture of our electric bus. And we will try to explain, I can show the content, the layout architecture, the battery architecture, our DC-DC converter, motor controller, our diagnostics which we have prepared, HV cable connections, electric bus charging means what problem we are facing and how we are diagnosing all things. In the meantime, if anyone has any question, maybe every PPT, once we go to the next, we can discuss that as well. So we'll start with the very basic, with what is electric bus and what are two types of electric bus categories are there, like what is autonomous, what is non-autonomous. So autonomous, which is keep the energy stored within the vehicle like our JBM bus, and non-autonomous is bus maintain a continuous supply electric energy from the outside the vehicle, like example metro. And there are three type of vehicle. What is conventional vehicle? One is hybrid and one is battery operated electric vehicle. So conventional, we all are aware that the fuel, then the engine and connected with the transmission, and the hybrid, which we have not proto anything we have not prepared. But this is also a concept in basically in car segment, that the engine and battery, they are connected parallelly in the connection. So there is a small
अच्छा,
size of battery.
एक एक कपिल कोई ट्रेनिंग दे रहा है इलेक्ट्रिकल बेसिक आर्किटेक्चर की ज्वाइन कर लो उन चीजों में कम से कम
Okay, Kapil,
And
continue, karo.
okay, and moving forward, that the battery operated electric vehicle, which we will discuss in detail in further PPT. So let's start with the basic layout architecture with respect to CAD. So all engineers who are there all have seen our 12-meter electric bus. I have taken the example of 12-meter our first prototype, an MMT bus. And for that we have prepared this CAD layout. So like starting with the battery. So all batteries in our 12-meter project are placed on the roof. So the rear side is consist of power distribution unit, where all battery power supply is distributed to the different auxiliary and motor. So in further PPT, we will explain the PDU as well in detail. And HVAC, that is all aware that HVAC unit is there. And the steering motor, which is in the front top side. And the BCS, battery cooling system, which is used to cool down the battery while charging and discharging in both scenario. Demister in the front side of the bus. We have this dual gun charging socket, which is used to charge the battery at 200 ampere. So in further slides, we will discuss about the charging process as well, means the how the charger and the bus, or how to say the CC, we called it CC, how they are connected with each other before doing the charging, how they are communicated to each other and what they are talking about, what parameter they are checking, and if any fault, the charging will be stopped, what will be written on the cluster, what will be written on the charger. So that we will discuss in further PPT in detail. So we have a specific engineer, as you all are aware about, that will like Shubham and Rohit, they are taking care for charging. They will explain in their PPT in further detail. So we have this motor controller. We have a separate PPT as well for motor controller as well. This we have a 6-phase motor. So what is the torque and how we are deciding the motor in our physical vehicle, and what are the parameters chosen during the motor selection. Yes, we have a air compressor as well, which is used to feed the air into the system. So as far as basic schematic is concerned, because we have seen just now the layout architecture. So as far as schematic is concerned, this is a basic layout which is not consist of any battery. So we have prepared a journal layout like the battery 1, 2, 3, 4, 5, 6. We can say we have a 8 battery as well, 6 battery configuration. We can have 4 battery configuration. And in future we have a multiple configuration also, which we are working as of now. So all this we have considered like 3 battery, which is connected in series, and later they are connected inside the PDU. And same another 3 battery which are connected in series and later they are connected inside the PDU. So we can say it is a true 2-string configuration which is connected inside the PDU. And the DC input voltage is around 600. We consider as a 600 as a nominal value. But if we talk about our 9-meter, 12-meter project, we have a 621 as a nominal input. Then we have a charging socket, and then after charging socket, we have a connect box, and then connect box, the connection is going to the power distribution unit. So this mainly the purpose of this connect box is the charging socket wires which are coming along with the charging socket have a length constraint, means they are providing us 1.5 meter maximum, and then this connect box is required. We can say this is just a connection between 2 high voltage cables. So we cannot connect just like a LV, we can use a jointer, something like that. So in high voltage, we have to be very conscious while doing the HV connection. So this is a connect box. We can say it is example how to connect two HV cables. So from the PDU, I'll come to the first output, that is the motor controller unit. So from the PDU, how it will go, that will be explained later. So in the schematic, so positive and negative wire is connected to the motor controller unit, and motor controller unit has a certain PCB and IGBTs switching frequency, which is used to give 3-phase output, or in our 12-meter project, that is a 6-phase output to the traction motor. So based on the accelerator pedal position and brake pedal position, these are the 2 basic input which is required by the motor control unit. So we'll discuss in detail as well. Then second point is about DC-DC, or we can say auxiliary inverter. So it has 2 function. One, it is provide us 600 volt to 24 volt output low voltage to charge the low voltage battery. In our conventional vehicle, we are using alternator, which is used to charge the low voltage battery, so that auxiliary 24 volt load can be drive properly, like our front light, rear lights, all ECU which required 24 volt supply. Then this DC-DC auxiliary converter also give us 3-phase AC output. As of now, the capacity is 30 kilowatt, for which the input is going into the HVSS. So this HVSS consists of basically the contactor and the MCBs, and we called it high voltage switching station. This high voltage switching station has a 3-phase contactor, which is controlled by our ECU, or we can say our multiplexing node. So when we have to switch on the air compressor, when we have to switch off the air compressor, that information is also coming to the multiplexing ECU through the brake system. So like if the air tank is filled, then we have a ground input which is coming to the our multiplexing unit, and that understand that now the air is properly up to 9 bar or up to 8.9 bar is filling the system. And इसका okay, and then there is a power steering system also. So power steering system is getting power supply all the time. I hope the PPT is visible to everyone, right?
No, it is not visible.
Visible, wait.
कपिल डिस्प्ले चला गया, किसी और ने डिस्प्ले लगा दिया, आप दोबारा डिस्प्ले करो।
अच्छा, सॉरी, फोन लगा गया डिस्प्ले। और कौन ट्रेनिंग दे रहा है? Now it is visible.
Yes.
Okay. Okay.
PPT मोड पे ले लो।
Yes. So moving forward from the power distribution units, direct supply is going to the, wait, let me open the pointer as well. The power supply is going to the battery cooling system as well, and the demister as well, and the HVAC as well. So they are controlled by a contactor inside the PDU based on them some logic input which is required to operate the all these auxiliary loads. So we
Kapil,
have a
Kapil,
hello.
just want to know. Hello, Kapil. Just want to know how BCS get the high voltage.
High voltage means that is directly coming from the PDU. Means the DC input is directly coming from the PDU.
So there is no requirement of HV or BCS.
No, that is a high voltage. That is a high voltage which is coming directly from the PDU.
दिनेश गरकोटी, आप क्यों डिस्प्ले करवा रहे हो यार? बार बार कुछ इश्यू आ रहा है दिनेश? ये डिस्प्ले
PDU is also it means to you PDU is also a converter DC to AC, right? Is it so?
No. That is a inbuilt converter is there for the compressor inside the BCS, and that is a DC BCS that working on that. So
Okay.
we are not, there is no converter inside the PDU. PDU is just a power distribution. Maybe we'll come on the PDU in the next slide. We will have a proper picture and we will explain step by step which contactor when it operate and when it gives supply to the which device.
कपिल, आपका ये कुछ बीच में दिनेश गारगोटी का कुछ डिस्प्ले व्हाइट बोर्ड आ रहा है, बिल्कुल चला जाता है बीच में।
हाँ, मैं भी वही बोल रहा था, ये दिनेश गरकोटी के मेरे ख्याल सिस्टम में कुछ प्रॉब्लम लग रहा है। दिनेश, आप सुन रहे हो क्या दिनेश? ठीक है, अभी लगाओ कपिल। ओ चला गया।
Now it is visible.
यस
हाँ
यस।
कपिल, ठीक है, ओके, गो अहेड।
Okay. So one small video which was shared by a service engineer. He has shared with us. That is also good. Maybe I can play that as well. It is visible.
यस यस।
Yes, visible.
एक ही पेन है, मैं यूज कर रहा हूँ।
Okay, this was the base. This was the basic architecture for our 12-meter electric bus. So next, so next we will move to the battery architecture. Although we are buying battery directly from the supplier, but maybe some people have few question. I prepared just one PPT for that, like high battery are configure, starting from the cell and moving to module, and then we prepare the pack and the complete system of the battery pack. So this is the basic architecture for the battery which we are using. Moving forward, this is a small detail for our Lenje DC-DC converter, which, although I explain the convert the 800 volt, or let's say it is a limit, means this device can work up to 800 as well. Although we have a 620 volt as a nominal voltage and 705 is the maximum voltage for the battery system if battery system is fully charged. So that convert to the 24 volt supply as well as auxiliary to the charge the unit. And we have defined some parameter as well, like what is the rated voltage, that is 800 voltage range is up to 848. Maximum current is 18.3 as a input. Maximum power, that is kilowatt, is 5.6, which is for the DC-DC. And this output voltage is the regulated voltage. We can set that value as well. Means if you want to set 27, 28, 28.5, we can set through the software. So the below architecture which tell how the DC-DC converter into the system, from the achieve battery string battery management unit, then it's go to the power distribution unit, then it's go to the DC-DC converter. So this DC-DC converter has a two capability. First is the application software is user friendly, means we we can set the parameter by using the Lenje tool. We can define some set of parameter, like previously we faced one issue regarding the over voltage in our 12-meter and MMT buses. So where we find that parameter along with Lenje team, and we have set that value, and later that problem is almost solved. The vehicle is under observation. The second is this device has an internal memory as well. So every time whenever there is a problem, for example, we have faced as well in MMT buses, if the coolant pipe is in because of any reason, so our temperature warning is come. And although that warning is coming on the cluster as well, that Lenje is overheat. But in that case, the internal memory, which called is DTC code, they mentioned complete report into that, means at what time, which parameter, and what is the DTC code for that, and why it has arrived. So complete data is coming into that DTC. So we can say this Lenje device is really a high-tech device which is able to give proper information if the failure occurs, means the device is offline, let's say, and later how we can check. So although that tool we don't have, there is a special tool. Even if the device is offline, you can capture that black box data from the Lenje, and you can figure out what the problem was inside the unit. If it is related to the diagnostic trouble code, which is already defined into the system, means someone has already pre-programmed all the diagnostic code, like this our temperature, this is also a diagnostic code. If it is already programmed, then it can properly measure that value, and even he can tell that value as well. So this is the all information about the DC-DC converter, DC-AC converter, which is used for the Lenje. Moving forward, I think Akash, if you tell something about this motor.
Hello. Good evening,
Yes,
everyone.
Akash. Yes, please.
About the motors that we are using. Am I audible now?
Yes.
So I'll just briefly explain about the motors we are using in 9 and 12 meter variants. So in 9 meter variants, we are using 3-phase motors, and in 12 meter variants, we are using 6-phase motors. And the reason being, in the 3-phase variants, we are not getting enough power for the 12 meter variants. That is why we are going for higher phase motors in the 12 meter vehicles. So I'll just briefly describe the characteristics of these motors. Uh, both of these motors are permanent magnet synchronous motors. For example, the rotor is a permanent magnet, and the rotor runs at synchronism. The maximum torque of both of these motors is almost same. The gear ratio being different provides higher torques in the 12 meter vehicles. The continuous torque of 9 meter variants, if you see, is higher than the 12 meter variants. The reason is because the continuous power of 9 meter variants is at the same speed of the 12 meter variants. That is why the continuous torque is higher. The maximum power which 9 meter motor can deliver is 215 kilowatt at 600 volts, and 12 meter and the maximum power of 12 meter vehicles is 250 kilowatt at 600 volts. The continuous power is 144 kilowatt for 9 meter variants at 600 volts. The RPM values are varying, like for example 1500 to 2000 RPM. If we consider the AES 41 reference, we'll see that the RPM value is 1500 RPM. This is defined by the supplier itself. The speed operating range of 9 meter variant is 0 to 2700 RPM, and for 12 meter variants it is 0 to 3700. So we are achieving the desired speed using the gear ratios that we are using in both the motors. The gear ratio for 9 meter model is 5.57 in BMTC and in Jhansi vehicle, and in 12 meter variants it's 9.05. So this is just the basic data about the motors. If anyone have doubt, we can discuss after the meeting is over. Or meeting after we conclude about the doubts on the motors. Thank you. Just like Kapil sir was explaining about the Lenze, that is, it has inbuilt memory. Even MCU also has inbuilt memory, and every time there is any fault inside the traction system, MCU gets the data and save it inside its memory. And using the Odin tool, which is being provided by the supplier Dana TM4, we can access that data about the fault which is happening in the system. We track and check the data using the GDD file, which means gather diagnostics data. We take that data, we study it, and we conclude whatever the doubt is. And I'll also tell you about the parameters that we are setting in 9 meter variants. For example, in 9 meter models, we were facing jerk related issue. Clear about why that was happening, and it was quite confusing at that time whether the issue was because of motor or the other components in the tractions in the powertrain. So we decided to control it. We decided to see whether we can control that issue through the motor side, and we found out that that issue could have done using the damping parameters which was present there inside the motor. So using Odin tool, which was those parameters were default disabled from the supplier side. So we enabled those parameters. We set the relative values. For example, at certain speeds where the jerks were coming, we set those values and enabled the damping parameters, and then jerks were controlled. After setting all these values, we declared to the supplier that we want to use these values. So that was something which was quite commendable at our end, and we did it ourselves. We told the supplier later. Yeah, so that's all from motor side. If anyone wants to know
the damping, why it is came into picture, because the electric axle is different and conventional axle is different. So there is always a small play in our conventional axle. So that is can be reduced by using this damping parameter. So anything, if particular question anyone would like to ask regarding the motor and motor controller, then we will move forward.
Hi Kapil, I have a question about this. There's a doubt that the continuous power we generally use when vehicle is running normal condition, and peak power we use when we are accelerating or going on a gradability. So what is important when I'm selecting a motor? Means you consider for the continuous power majorly or for the peak power? A general answer you can give.
Hi sir. For a general answer, if I want to give for the power related side, we just select the continuous power. But if you want to talk at grade conditions or higher and or certain kind of things, we consider about the torque and not the power condition.
Okay, and for example, if in my calculation, if I'm required 100 kilowatt continuous power, so matlab, how much percent you will select for motor for if I'm required 100 kilowatt power? So you will require a matlab, how much percent you will select a motor for 100 kilowatt? Means you will run on the 75% of the rated requirement or 90% or 95%. Can you understand my question?
Sir, I am, as far as I can understand, I am telling you regarding the motor selection thing, we are just going for the maximum torque kind of thing, and for the maximum speed, we are using the RPM kind of thing, and we are looking at the gear ratio whether we can achieve both of these things.
Okay, and then
But
that's
one
okay.
thing I would like to add here,
My
while selecting motor, see, whenever we do running on the city application, so we are using only 40%, means like our 12 meter motor is 189 kilowatt hour. So we are only using 40 to 80 or 85 kilowatt hour at a time. But because of this 17% gradability requirement, we have to use a motor with the higher specs as well.
yes, Kapil, I was asking this only. Means
Yes.
for the rated, if it is 100 kilowatt requirement, so you
Yes.
are running on the 40% of
Yes.
real rated
Actual. This is actual
requirement.
data
So that
which
give
we
you the
could
best
able to
efficiency.
capture in the field. So this is the
Okay,
actual data.
okay.
कपिल मेरा एक क्वेश्चन है यहाँ पे जैसे अगर मैं 9 मीटर और 12 मीटर की बात करूँ इसमें जो तुमने पहले क्राइटेरिया अभी जिसमें क्राइटेरिया बताया था मैक्सिमम टॉर्क और कंटिन्यूअस टॉर्क इन दोनों केसेस में तो 9 मीटर का जो आपका 3 फेज PMSM जो मोटर है उसका टॉर्क दोनों केस में ज्यादा है हम लोग मतलब ये 6 फेज मोटर पे क्यों कर रहे हैं
सर 6 फेज मोटर पे हम जा रहे हैं पावर रिक्वायरमेंट के लिए। आप मैक्सिमम पावर रिक्वायरमेंट देखिए 250 है मैक्सिमम पावर जितनी मोटर डिलीवर कर सकती है और इसकी स्पीड भी ज्यादा है इसीलिए।
हाँ नहीं वो
अगर हम
तो समझ
इस
गया था लेकिन जैसे आपने बताया था ना मोटर सिलेक्शन का क्राइटेरिया जो आपने बताया था टॉर्क का तो उस बेस
हाँ
पे
जी,
मैंने
वो सर गियर रेशियो के ऊपर है। अगर हमारे पास और ज्यादा गियर रेशियो होता तो हम ये स्पीड टॉर्क में नीचे भी जा सकते हैं अगर ज्यादा का गियर रेशियो लगा सकते हैं और हमें हायर
नहीं,
स्पीड की
इसमें
मोटर मिलती है
एक्चुअल क्या है ना, देर इज अ ट्रेड ऑफ बिटवीन स्पीड एंड टॉर्क। अगर आप एक्सल बढ़ाओगे तो एक चीज मतलब दोनों यूनिवर्सली हो जाएंगे, तो आपको दोनों को ट्रेड ऑफ करना पड़ता है कहीं ना कहीं, ग्रेडेबिलिटी को और स्पीड को भी।
ठीक है ठीक
Hello,
Yeah, yes, please.
sir. I just want to ask what is the actual purpose of this three-phase motor and six-phase motor, sir? I mean, other than this voltage, what you have said already.
like what's the purpose? The purpose is for traction only. What specific you want to ask? Can you be more clear?
I just want to ask, sir, is there any impulsion related purpose for the three-phase motor and six-phase motor? Because somewhere I have seen the nine-phase motor also in that traction motor.
Yeah, that is for higher torque requirements, even higher than both of these variants. See, it all depends upon the requirement that we are. We just have the set of requirements. We go for the suppliers, and if they are able to deliver that requirement, then we go for that motor. The purpose is very simple. If you ask certainly about the permanent magnet, why we are using it's because higher power to weight ratio and higher power densities and then all these things. But if you are asking about the phases, why we are going for phases, 3 phase, 6 phase, 9 phase, then it depends upon the requirement.
Akash, Krishna this side. I have one doubt. Why we are using the PSSM basically? In place of PSSM, we can use the induction motor with the help of VFD, because we are using the PMSM. Magnet is having the tendency to, over the period of time, it will lose the magnetism. So we are using this motor vehicle of 12 years, 15 years.
Right, sir.
So it will
Right, so
deteriorate the life.
certainly, so certainly there are pros and cons associated with both these motors. But if you see about the induction motors, the rotor is having windings, so there are losses associated with it. So there is a trade-off, as Kapil sir has clearly explained. Even the induction motors has not proper cooling. For example, I went to ABB once and I was looking at the motor. It was about 800 kgs and it was able to deliver only power of 90 kilowatt. So I was very shocked at that time, and that was certainly surprising for me. So I was thinking that maybe this is one of the reason. Also, if you see the efficiency range of both these motors, it is quite comparable, but induction motors has slightly less efficiencies than the permanent magnet motors. And if you talk about the magnetism, losing of magnetism of the rotor of synchronous motors, then we are providing, first of all, we are providing water-based cooling. And then certainly logics are made inside it. Like if the temperature is going to raise above this value, then the motor will shut off. So I think, and even if you look at the control side, induction motors controls are similar to that of synchronous motors, but their performance are not that much comparable to synchronous motors. That is why synchronous motors has an edge over the induction motors.
Okay. Okay, thank you.
And Krishna, one more answer, which is related to motor, because the localization is also a factor while selecting a component.
Okay.
So this Dana has already a facility now. They already come up with a facility in India, and they are renowned company, and their performance is also very good. Although previously we have worked with CG as well, as Akash explained, we face the gradient issue with the CG motor. That was the induction motor.
Okay. So anybody is in India other than Dana who is manufacturing the motor and the MCU?
See, we are working with the many supplier. Like he told, he visited ABB as well. We work with the Siemens as well. So there are a lot of factor while selecting this parameter. The cost, that cost is important parameter. And
Okay.
why Dana is able to deliver in low cost, because many OEM are buying from the Dana itself. So because of the volume, they have a good cost reduction, and they started the localization as well.
Okay. Okay. Thank you. Thank you, Kapil.
Okay, maybe we can move to the next slide, right?
Yes, yes. Please proceed.
Okay, this is the dashboard, our cluster, we can say. So we have taken multiple input from the multiple projects which we did previously, like we worked with the Acti as well. We worked with the Asia Star as well. So we have taken the input from their cluster as well, and we try to prepare a cluster which should be good in information. The maximum information has to be arrived on the cluster page itself, and we try to rid of the codes as well. So means we try to write down something which give clear indication, like in the cluster current scenario, you can see error below screen. Let me use this. So first we have defined the info and error separately. So which is a change in JBM cluster. So if there is a info that has to become in the format of info, like tailgate is open, that is actually not an error. That is a info. If you are not able to drive the vehicle, so you have if you're not able to crank the bus, then you have to go and close the tailgate, and then you are able to crank the bus. And error is separate, like brake pressure is low. If any node is the SCP-12 actually. So if node error is there, that will come proper in written format. But in the main page, there are two pages. One is the main page and one is the separate page for the error. So here it is written BR press LO. It means I know that brake pressure is low. But if you go by pressing this enter button, you have to remain on the same screen. You have to just press the enter button. That will directly take to the error page, where you will clearly find it's written clearly brake pressure is low. So this is the difference from the our previous projects as well, and the difference from the existing OEMs as well. So all the telltale information which is mandatory, which is required for the homologation and which is required for the driver itself, they all are placed as a digitally, and some which is the part of the cluster itself, like the VCU can, brake pedal, ABS, some informatory like front fog lamp is or not on or not. And this is the emergency open if someone has pressed, if any steering fault will come, so this type of symbol will come. This is the state of charge if some disabled person stop request is pressed, and this is a simple stop request. So all information try to accommodate on the first page itself. And we try to place some picture with the error itself, like for the instrument cluster, if there is a HV contactor error. So why this HV contactor has arise, that will explain in the PDU page, but it is written here HV contactor error. And similarly, we have tried to place that if vehicle is in charging mode, you can see the symbol that the charger is connected. Moving forward, okay, this is just we have placed for the page from the FAME accessibility criteria, where they have defined the e-bus with the length above 9 meter up to 12 meter. What is the minimum range requirement and what is the minimum range requirement? So they have defined the some parameter with GVW, with HVAC on, with HVAC off, and with AIS standard. So this has to be tested separately at ICAT to meet this criteria. Moving forward, see, when we started preparing our first electric bus NMMT means the Silex model. So we did some activity over the bus, like the cable torques and value defined on the terminal, because we have faced issue as well. So we try to, this table is complete, try to cover all HV component with respect to all HV cable. And this table is already placed in the all installation drawing of HV cable, where the joint exercise with ME and with the quality, we defined all the torque values as well as the supplier recommended value as well. So this is helpful for the production as well. This is really important. We have a separate page for the gland as well to explain the gland procedure, that how the gland should be tied over the bus. So that Rajat will explain separately on that. But we defined lock nut, dome nut, how to tie it, what should be the torque value. So that proper presentation is already prepared separately. We will flash today itself.
कपिल भाई, ये जो स्टैंडर्ड आप दिखा रहे हो टॉर्क का, ये स्टैंडर्ड फॉर्म में रिलीज है या फिर ये आपका जो IFD वगैरह रहता है उसमें दिया हुआ है ये अलग से?
Sir, this is prepared in IFD only. This all information you will get in HV cable and component. There is a single drawing, so that defined all the values.
अच्छा, मतलब ये सारी एक ही जगह पे मिल जाती हैं?
Yes, yes, yes. Only one drawing.
ओके ओके, तो ये 9 मीटर और 12 मीटर के लिए कॉमन है या अलग अलग है?
The drawing is separate, means maybe some value could be changed because the motor terminal is changed in 9 meter and motor terminal is different in 12 meter. So some value will be different, but almost you consider 90% value will remain same. Like battery, the battery will remain same for all the system. PDU will remain for the all the projects.
तो जो हम लोग बात कर रहे थे एक बार, तो ये अगर हम ये दोनों को रेफर करें तो हमारा काम हो जाएगा ना फिर?
Yes, sir. Yes,
Great.
it will cover. And I request to all team as well, if they found any discrepancy, any gap, anything is missing which is not provided still in the drawing, so they can immediately contact with us. We will definitely improve the drawing and incorporate in the drawing itself. Although we tried our best, consider all inputs from the team itself.
ठीक है. Okay.
This is just we have placed because we faced the battery problem in NMMT buses, although now we are not facing. So they have defined in the drawing, and we have put in the drawing also the torque value for the HV battery connection. This is the motor connection, because we have put here that how this connection look like and how it should be connected inside the motor, as well as the MCU. Both are same. So torque is already defined in drawing, that has to be also need to be taken care properly. And this is the Lange exploded view. So if you see this cover has to be fitted properly. The reason is that this device has a sensor somewhere here, and if the cover is not closed, the Lange will not work. Means it has a sensor which detect this cover is connected or not. And this is IP69, and all connection of the HVR IP67. Moving forward, I think this is the PDU. Maybe Rajat will start explaining one by one. First, he will explain all the components which all we can see here, and then he will explain the functionality of each function. And if anyone has any question after finishing his comment, people can ask. Okay, Rajat, over to you.
Okay, hello everyone. This is Rajat. Let's start about the details of components. Okay, let's start from the left side. We have two types of PDU. The bigger one is for the 12-meter vehicle, and the smaller one is for the 9-meter vehicles. So all 9-meter will have a same size of PDU as for the outer dimension, and 12-meter will have the same. And this size of the PDU depends on the number of battery strings we are using. Like for 12-meter buses, we have a 4-string. And for 9-meter vehicle, we have a 2-string in BMTC vehicles, 3 strings in Jhansi vehicles. And also depends on the number of charging sockets we are using. So in 12-meter vehicle, a bigger one, we have a 4-string and a 2 charging socket. And we have a VCU inside the PDU. Like if you will look for in the drawing of the PDU, it says SCP-10. It is the electronic component control unit, which has a which is used to control the contactors and communicate with the BMS for operating of that contactors. Like it consists of one of the CAN connection, which is used to communicate with other nodes in the vehicles, like cluster and node 1, 2, 3 as well. And there are 4 connectors for input. There are 4 IO connectors. All of them has some input pins and some output pins. Input pins are used to detect the inputs, like anything. IMD is saying that insulation is okay or not okay, contactor is on or not on. So all type of inputs, feedback from contactors, feedback from IMD, feedback from BMS are sending signals to this VCU and will be given inside VCU through input pins. And all the output pins are used to control the action, like controlling of the contactors and all. So like we say for the contactors, any of the logic, if contactor is trying, we have to switch on the contactors. This VCU will give 24 supply to the contactor, and after turning on of the contactor, a 24-volt feedback will come through the input pin to the VCU. In this way, a operation of contactor completes. And we have a BMS inside this PDU. BMS communicates with all the battery strings and also with this VCU to proper functioning or to proper channel the power flow. We also have a insulation measuring device which is used to measure the integrity of insulation, like any high voltage bus bar or cable or component doesn't get shorted to the vehicle chassis, like for the positive supply and also for the negative supply. If any of the device compromises for the insulation, this device is well capable to detect that and shut down the overall high voltage system. And we have a limit switch also in this PDU for switch off the high voltage whenever the cover of the PDU is opened. And we have some fuses, some contactors, bus bars for power flow, and some resistors for pre-charging of the motor controller. Let's talk about the power flow of the. In bottom side, there are 4 strings. Right one, leftmost is the 4th string, and so on for the 3rd, 2nd, and 1st. We have 2 cables for 1 string. One is the positive one. The one in there is a bus bar, and fuses is the positive supply from the battery string, and the longer wire, longer cable one is the negative one. So fuses and contactors are connected in the positive cable of the string. And for the battery string part, we have a fuse of 250 amps and a contactor of 250 amperes. We also have a current sensor in each of the battery strings. Like in 12-meter PDU, we have a 4 battery strings, so we have a 4 current sensor, and these sensors give actual live current value to the BMS for proper functioning of the or proper channeling of the power. And after that, we have we have a output for traction motor. And first left one is the positive output, and right one is the negative output. And these 5 resistors are used for pre-charging of the motor control unit. And let's go for the charging socket part. We have a 2 charging charging socket in the vehicle. So there are 4 cables. First one for the charging socket 1, positive, negative, and second one is the charging socket 2, positive and negative. We have contactors in all the 4 cables for the positive and negative of both the charging sockets for protection from the shock if anyone will touch the charging socket, so that it is a safety part. We are using contactors in all the cables, and we have a fuse of 250 amps in both the positive cables of charging socket. And let's go for auxiliaries. We have 4 types of auxiliaries we are controlling through the PDU. First one is the leftmost is the BCS, leftmost is the Lenje. So we are using contactor in Lenje device and a fuse of 50 amperes in the for that supply. After that, there is a demistor. We are using contactor, also a contactor for the demistor. Third one is the HVAC, and last one, rightmost, is the BCS. BCS and HVAC don't have a contactor because individual component has a contactor for protection and controlling of the power. So we aren't using that. And for extra, we have a IMD. Let's talk about IMD. IMD, we are using two wires from the one from the positive bus bar and other from the negative bus bar. And IMD detects the faults by injecting a pulse into this high voltage system, and if IMD detects return of that pulse through its ground point, then it shut down the high voltage system by giving feedback to the VCU, which is also present in this video. So in this, I think everything is covered.
Okay, if anyone has question regarding PDU.
कपिल मेरा एक क्वेश्चन है हम दो सॉकेट यूज करते हैं चार्जिंग के लिए है ना तो हमारे जैसे आप बोल रहे थे तीन बैटरी पैक के स्ट्रिंग बनाया आपने 3 बैटरी सीरीज में है फिर 3 सीरीज में है तो ये एक सॉकेट 3 बैटरी से कनेक्टेड है क्या और दूसरा 3 से कनेक्टेड है क्या
नहीं all battery strings are connected to the common bus bar, the lower one. Positive one is the lower bus bar, the longer longitudinal bus bar we are seeing, and all the negative connection of all the strings are connected to the negative bus bar, and these two bus bars are the common point for all types of load. All battery strings supply power to these two bus bars, and all other loads are taking power from that two bus bars. So whenever a charging occurs, the current will flow from this point also. It's like we have studied a Kirchhoff law, KCL rule. So this is applied here. So it's not like we are charging first string, second string. In case if contactor is off of that string, at that point the current will not flow. Otherwise, if all the contactors are on, charging will occur for all the strings. Loads are also simultaneously on for all the auxiliary.
मेरा ये तो आपने बहुत इंटरनल का बता दिया मेरा बोलना ये था कि हम जैसे 2 चार्जर के यूज कर रहे हैं सॉकेट एक यूज करेंगे
दो चार्जर इसलिए यूज कर रहे हैं कि हायर चार्जिंग रिड्यूस चार्जिंग टाइम
और अगर हम 4 यूज कर रहे हैं इसकी जगह 4 यूज कर लें तो और रिड्यूस हो जाएगा क्या
ऑब्वियसली हो
instead of 2 sockets 4
wait Rajat wait see the charging socket has a capacity of 200 ampere okay one charging socket so you cannot go beyond as of now like people some are working on 300 as well and liquid cooled charging in the bus at 500 as well which is not in the SOP phase till yet but the maximum capability is 200 ampere and there is a standard which we called CCS2 which is defined by the automotive industry standard we call the AIS standard or there is a Society of Automotive so they have defined the CCS2 that define the charging either with the single gun or either with the dual gun as of now although people have started with the 3 gun as well but till now it is not implemented anywhere till yet
so Kapil, my question is as you mentioned CCS2 okay so in India whether we are at the stage that whether we are doing charging with the two gun dual gun sorry so is
yes dual gun
okay
dual gun we are doing dual gun even Tata has done Ashok Leyland has done so multiple player is doing that dual gun charging because so the limitation is no maybe I can use only single gun why I want to travel 2 wire from charging socket to PDU I can use 500 ampere socket single socket and can charge the bus very easily but for that the product charging socket is not in SOP yet by any supplier and that socket will be liquid cooled even the charger the gun which will come to the charging socket will be also liquid cooled so that is development is going on but still is not in SOP.
So according to you, even though it is dual gun, but we are using only single point, right? Is it so? Right?
We can charge with the dual gun as well. Means we have a capability. We can charge with the dual gun and single gun. See, the thing is that our system is capable doing dual gun charging. But any instant, if bus is any place where single gun charger is available, I can charge with the single gun as well. You got my point?
हम कस्टमर को जो टाइम बताते हैं चार्जिंग का वो हम दोनों का कंसीडर करके बताते हैं कि सिंगल गन चार्जिंग का बताते हैं चार्जिंग टाइम
ड्यूल गन
व्हिच डुअल गन का बताते हैं
यस
ओके कपिल ये बस बार का फंक्शन कुछ होता है क्या मतलब बस बार इसका कुछ स्पेशल नाम है क्या ऐसा कुछ नेगेटिव पॉजिटिव जोड़ते हैं इससे बस बार का फंक्शन क्या है एक्चुअली
पावर फ्लो सिंपल is single point of contact to follow the Kirchhoff law. सो कहीं पे आके आपको सारा चीज एकदम जोड़ना पड़ेगा ना एक साथ, तो वह वो एक बस बार का पॉइंट है जहाँ पे आप सब चीज आके जोड़ देते हो एक साथ।
ओके। और कुछ आर्किटेक्चर में हम एज जंक्शन बॉक्स भी देखते हैं अपने व्हीकल आर्किटेक्चर्स में, उसको आप सीसीबी जंक्शन बॉक्स ही है क्या, चार्जर कनेक्ट बॉक्स जिसको बोलते हो? ये जैसे
हाँ,
अभी
वो
व्हीकल में
मतलब अगर उसको आप खोलोगे उस जंक्शन बॉक्स को, उसके अंदर भी आपको सिमिलर टाइप का आर्किटेक्चर ही मिलेगा। मतलब एक पॉइंट ऐसा जरूर होगा जहाँ पे आके
जंक्शन बॉक्स
सारी
में सिर्फ
बैटरी
एक ही चीज होगी।
इकट्ठी कनेक्ट होंगी।
एक चीज और क्लियर करना कपिल यार, कि हेलो कपिल, एक चीज और क्लियर करना कि what for charging we are using a constant current method or constant voltage method, just, and what is the reason behind it?
That will come in detail while during charging.
Okay.
During charging we'll talk about CC, CV and we'll talk, because वो मेथड है कब जाके आपको कांस्टेंट वोल्टेज पे कन्वर्ट होना है।
हाँ, जस्ट वांट टू एक्चुअली मुझे समझना था, मुझे थोड़ा समझना था, इसलिए चलो जब बताओगे तब विल क्लियर इट, ठीक है? ओके।
Hello, sir.
Kapil ji, I have one doubt. Hello, Kapil ji.
Yes, please continue.
Actually, we are not using any contactor for negative cables, right? The power comes from the battery, we are not using it. But when we are giving power to the traction motor, we are using the contactor for positive as well as negative. Am I right?
Yes, right.
So what is the significance of negative contactor we are using in the negative flow, specifically for the traction motor and controller?
Yes, that is a pre-charge function which is linked with the negative contactor as well.
Okay.
तो वो सर्किट है पूरा, मतलब यहाँ पे फिर वो हाथ से बनाना पड़ेगा कि वो नेगेटिव क्यों सीन में आया, कि नेगेटिव कब ऑन करना है, ताकि पहले उसका कंट्रोलर प्री चार्ज जो उसके अंदर कैपेसिटर लगा हुआ है वो चार्ज हो जाए एक लेवल तक, मतलब कंट्रोलर की जो वोल्टेज है वो बैटरी की वोल्टेज से मैच कर जाए।
पोटेंशियल डिफरेंस ना हो। ओके।
हाँ, प्री चार्ज में क्या रहता है ना, कैपेसिटर मतलब विद इन सेकंड वो चार्ज करता है और इतना फास्ट चार्ज करता है वो कि उसको आपको कंट्रोल्ड करंट देना होता है। अगर आप कंट्रोल्ड करंट नहीं दोगे तो आपको वो डिवाइस डैमेज कर देगा।
ठीक है कपिल, कंटिन्यू करो नेक्स्ट फर्दर।
हेलो सर,
अरे इसका बंद करो।
हेलो
कपिल, मेरा एक क्वेश्चन है।
हेलो सर, आई हैव वन क्वेरी सर।
हाँ पूछो, कंटिन्यू पूछो।
Yeah, sir, actually we are using two BMU right now, one master and one slave.
Yes.
What is the difference between both, sir?
The only difference is the one BMU can measure only 3 battery current. We have used here 4 sensor, current sensor.
Yes, sir.
Okay, so
yes,
these master is capable only to read the value of 3 sensor. That is the limitation only.
Oh, okay, sir. So other one is reading the one only, but it can measure another 3.
It can another one. Yes, right.
Okay, sir. And one more query, sir. See, string fuse ampere rating is 250 ampere, sir.
Right.
At the same contactor ampere rating also 250. So is it
yes.
Okay, sir? I mean, usually the the fuses rating should be higher than the object and or
the contactor is a independent for the design point of view. Means you should not consider the rating for the contactor. Like if it is 200 ampere is the current requirement, then you can go up to 250. Even I can use 300. So contactor is just a relay. It is a switching, but it has to meet the minimum criteria. But yes, fuse has to be properly designed with respect to temperature, with respect to current. There are multiple factors. There is a fuseology technology. Based on that, this fuse size in HV cable is decided.
Okay, sir. So in this case, sir, the fuse always will ensure that in condition of the higher voltage or sometime the fuse only will blow, or it will affect the concept also sometime.
No, it definitely it will blow.
Okay.
The fuse which is inside the PDU, definitely it will blow, and we have faced this issue in NMMT buses as well, not issue. I will say the charging socket was the water ingress issue, and there was a short circuit inside the charging socket. So every time our fuse has blown up, every time.
Okay, sir. Okay. Thank you, sir.
Kapil ji, this is the scenario for the fuse selection. In that case, I have one doubt. I have seen in specifically in BMTC vehicle, our Lange output maximum current is 200 ampere. But whereas we are using the fuse of 400 ampere. Lange output, DC Lange output.
Lange, you are talking about 24 volt for your PDU.
Yes, 24 volt. Yes. 24 volt from the Lange to LV battery. In that circuit, we are using the 400 ampere fuse, DC fuse. Whereas our output is only 200 ampere.
But I remember that is carry forward from the CNG as well, and that is a short circuit protected already. Means the purpose of the fuse is the short circuit protection. Usually what we use that, right? So
yes,
that
right.
short circuit protection will definitely get with the 400 ampere as well. But I need to again review that point that is taken care by our LV team.
And same thing with the cable also. Actually, Lange is suggested to use the 70 square mm cable, whereas we are using the 95 square mm. So if you reduce it to 70 square mm, that is also cost saving.
Yeah, that definitely that will be a cost saving, but that need to be that's why that is a need to be a design review properly.
Okay. Then specifically for 9 meter, where the cable length is also short compared to 12 meter.
Yes, we definitely we can review that point. This
Okay.
particular point you have to need to take up with the LV team, like the low voltage. You have to take up with them. However, if needed my support, I will be available.
Okay. Yeah. Please continue. Yes.
कपिल एक लास्ट क्वेश्चन है, इसमें जो आपने बोला है VCU, तो ये एक्ट एज अ मतलब मेन ब्रेन ऑफ द PDU और व्हाट, मतलब ये सारा PDU को यही कंट्रोल करता है?
हाँ, सारा PDU को यही कंट्रोल करता है, बट द व्हीकल ब्रेन इज लाइज विद द क्लस्टर.
ओके, मतलब VCU को जो भी इनपुट मिलता है वो क्लस्टर से मिलता है. आफ्टर दैट VCU विल एक्ट अकॉर्डिंगली.
यस.
थैंक यू.
So next
वोल्टेज इंटरलॉक का जो है HVIL का, वो कंसीडर किया है आपने ये?
हाँ, यहाँ HVIL हमने इसके थ्रू दिया है ना, लिमिट स्विच के थ्रू.
ओके. नहीं, क्या पॉइंट्स है व्हीकल में HVIL रिलेटेड, वो है क्या?
Every high voltage component has to be considered to be HVIL triggered. If you start from the motor controller, Lange, PDU, connect box, so they all are considered to be as a HVIL input. If any one of them is open, the high voltage will off immediately. Okay, now we will move to the next section, which is related to charging. Let's move to the second point. Wait a minute. So Shubham, maybe you can start explaining slowly each step for the charging, because this is new for everyone and it could be interesting as well.
Good afternoon, everyone. So let me talk about the electric bus charging process. So coming to the charging process, so first of all, when the vehicle is have to be charged, so our bus has to be HV on. So we have the charge enable switch in our vehicle. So when we press that charge enable switch, the vehicle is HV on, and after that all the charging process will start. So after that, when coming to the first point, mating. So when the charging gun is connected to the vehicle, so it goes to the initialization phase. In this initialization, the charger sends the CP and PP messages to the EVCC. The PP is changed to 1, that the gun is connected, to tell the EVCC that the gun is connected, and CP is the control pilot that will communicate, that will make the communication between the this charger PLC and the EVCC. So when the control pilot changes its CP duty, the EVCC locks the motor of the charging socket so that the gun cannot be removed during the charging. After the motor locking, the authentication process starts with the EVCC. So in this authentication process, the EVCC and the charger sends the messages, like the EVCC sends the messages of the current SOC of the vehicle, current voltage of the vehicle, so demand voltage and demand current. So after the intercommunication of the this messages,
शुभम एक सेकंड सिर्फ, आप ना बस और चार्जर बोलो, EVCC और CC बोलोगे कंफ्यूजन रहेगा, आप बस और चार्जर बोलो, ओके? हाँ.
So after the authentication between the bus and the charger, so the process goes to the cable check, where the charger sends the high voltage up to 700 volt with on the vehicle to check if there is any insulation failure on the vehicle or not. So if the insulation checked by the charger is greater than 350 kilo ohm, 350 mega ohm. So just hold a sec. Hello, sorry. If the insulation checked is greater than 350 kilo ohm, so the charger will go to the pre-charge state. Else, if there is any insulation failure in the vehicle or the charging line, so it will stop charging. So if it will go to the pre-charge state, here the charger builds the voltage that is demanded by the bus. So if the bus bar voltage, that means the battery voltage in the bus is around 620 volt. So charger will build the voltage up to 620 volt plus minus 20 volt, with limiting the current up to 2 ampere. So when this voltage is built up to 620 plus minus 20, so the contactors present inside the PDU, that will be closed by the bus, and after that it will go to the charging state. So in charging state, the charger will increase the current up to the required current till the vehicle is charged full. Or if we stop the charging locally, or if there is an error, so charger will decrease the current and the voltage of the charger, and then it will go to a terminate state. So after the termination, we have to remove the guns. That is a necessity. So if there is any failure, due to which if there is any error due to which charging has stopped, so we have the page on the cluster that will show for what reason the charging has been stopped. And in fact, the display of the charger will also show the error messages due to which the charging has stopped. So based on that, we usually diagnose what is the root cause of the stopping of the charging process. So next.
But you should tell us about USB, Shubham, that's
Sir,
HVMC box.
आगे
Okay.
बताऊंगा.
Next slide. Wait a minute.
Yes, sir. Yes. So you can see this is our dual gun charging CCS2 charging sockets of the our DTC bus, and this is the below is the CCS2 charging gun from charger side. So during the charging, as you can see from the image, there is one page which is telling the all the information regarding the charging. The PP state that will tell the bus that the charger is connected. The CP state or the CP duty that will make the communication between the bus and the charger. So this is the motor state. That means the motor is locked. We cannot remove the gun. So there is the socket temperature, which will tell us that the temperature is not high. So it will the charging is okay. And there is one socket voltage. So you can see, so we have one HV MCV box, high voltage measurement connect box. So basically this box was used to measure the voltage on the sockets. So the voltage the charger is giving, that is measured by this HVMC box. So if there is very high voltage in the charger, like the charger is giving more than 700 volt, or because the charger is 1000 volt rated, so if the by any chance the charger gives 1000 volt or 800 volt, and it is beyond our limit, like the battery needed 620 volt plus minus 20, so the contactors will not be closed by the bus. So we will protect the high voltage to come to the vehicle. So coming to this next, there are charging states. So all the states that I've told you, the mating state, the initialization, the motor locking, the pre-charge, the charged, and the termination, all the states from which we can see from this page that in which state the charging is going on. And all the errors are also there in the last line, like PP error, PE error, and motor lock error. Okay, thank you.
Okay, any question on charging?
कपिल, मेरा एक क्वेश्चन ये था कि हम जब चार्ज करते हैं तो जैसे आपका 621 आप एवरेज हम नॉमिनल लेके चलते हैं, और ये फुल चार्जिंग कर दी इसने तो ये 750 वोल्ट तक जाएगा ना?
705।
हाँ, तो फुल डिस्चार्ज मतलब हम जैसे 20% एसओसी पे आ गए हैं तो ये नियर अबाउट आपका 550 वोल्ट तक चला जाएगा, मतलब 6 नॉमिनल से नीचे आ जाएगा, है ना?
580
तो मेरा क्वेश्चन ये है कि हाँ 580, ओके। तो ये मोटर जैसे हमें जब मोटर को इस मतलब एक बैटरी है जो 520 वोल्ट पे चार्ज है और एक है 750 कंडीशन पे है, तो दोनों टाइम पे ये मोटर को मैं जब इसको पावर दूंगा तो ये कैसे मतलब मैनेज करेगी? मतलब ऐसा होगा क्या 7 फुल चार्ज है तो ज्यादा पावर डिलीवर करे, जैसे मेरी मोटर की रिक्वायरमेंट जैसे 621 वोल्ट?
एक्चुअली क्या होता है, जो बैटरी की वोल्टेज जब फुल चार्ज है लेट से 700 वोल्ट है, और जब कम डिस्चार्ज है लेट से 600 वोल्ट है, पर जो मोटर पावर ड्रॉ करेगा वो व्हीकल डायनेमिक्स या लोड जो व्हीकल को रिक्वायर्ड है उसके हिसाब से करेगा। तो अगर आप कह रहे हो कि 700 वोल्ट पे लेट से कि एक सिनेरियो है जिसमें व्हीकल जितना भी पावर ड्रॉ कर रही है 700 वोल्ट पे पावर ड्रॉ कर रही है, और वही व्हीकल 600 वोल्ट पे अगर सेम पावर ड्रॉ कर रही होगी, बट इस केस में करंट ज्यादा होगा, लेकिन ओवरऑल जो पावर रिक्वायरमेंट मोटर को रिक्वायर्ड है वो उतना ही ड्रॉ करेगी। आप अगर 700 पे हो तो भी पावर उतना ही रहेगा, करंट कम रहेगा, 600 पे हो तो भी पावर उतना रहेगा, करंट थोड़ा बढ़ जाएगा करस्पॉन्डिंगली, बट इससे फंक्शनैलिटी पे कोई भी हिंड्रेंस नहीं आएगी। हाँ बोलिए।
ओके, हाँ मतलब मोटर का जो रनिंग है वो हम मतलब मोटर को जो पावर चाहिए हम कभी करंट कांस्टेंट कर लेते हैं, कभी मतलब वोल्टेज कांस्टेंट करते हैं, दोनों का ट्रेड करके हम
ये
पावर बैलेंस करके
करना नहीं पड़ता है, ये ऑटोमेटिकली होता है।
हाँ, मतलब जैसे पहले अर्जुन पूछ रहा था ना कि ये मतलब कांस्टेंट वोल्टेज पे हम चलाते हैं कि कांस्टेंट करंट पे चलाते हैं, तो ये मतलब अपना बैटरी में जितना वोल्ट है उसके हिसाब से वो करंट को मल्टीप्लाई करके
ये जो कांस्टेंट करंट और कांस्टेंट वोल्टेज की बातें है ये चार्जिंग में होती है, डिस्चार्जिंग के टाइम ये नहीं होता। डिस्चार्जिंग के टाइम वोल्टेज कांस्टेंट है और धीरे धीरे एसओसी के रिड्यूस हो रहा है।
ओके, थैंक यू।
इसमें मेरा एक क्वेश्चन है, इसमें चार्जिंग के टाइम भी प्री चार्ज सर्किट होता है इसमें?
हेलो,
हेलो
यस,
शुभम, मेरा एक क्वेश्चन है इसमें, चार्जिंग के टाइम भी प्री चार्ज सर्किट होता है?
हाँ प्री चार्ज होता है।
ओके,
जो प्री चार्ज स्टेट है, जो प्री चार्ज स्टेट है वो इसीलिए है कि ड्यूरिंग प्री चार्ज जब तक द बैटरी वोल्टेज अब ये चार्जर अटेन नहीं कर लेता उस टाइम तक ये करंट को लिमिट करके रखता है 2 एम्पेयर से नीचे।
ओके,
हाँ, तो बट ये सर्किट हमारे पास नहीं होता, ये चार्जर का वो होता है।
ओके, चार्जर का सर्किट होता है।
प्री चार्ज वोल्टेज
वीडियो में नहीं है
चार्जर
इसलिए मैंने पूछा। यस, वीडियो में प्री चार्ज नहीं है इसलिए मैंने पूछा।
नहीं वीडियो में नहीं होता, वो चार्जर में होता है।
चार्जर
प्री
में
चार्ज
होता
में
है, यस
कनेक्शन
राइट।
करना चार्जर का काम है।
ओके, और एक क्वेश्चन है मेरा, बैटरी का जैसे चार्ज करते हैं तो बैटरी का टेम्परेचर शूट हो सकता है, तो उस कंडीशन में बीसीएस हमारा कंटिन्यू रनिंग में रहता है?
हाँ, बीसीएस जो है आपके बैटरी के टेम्परेचर के डिपेंडेंट ही होता है।
बट इन दैट केस हम सीसीसीवी जो बोल रहे हैं चार्जिंग का, वो कैसे मेंटेन करते हैं?
वो बीएमएस मेजर कर रहा है। बीएमएस ड्यूरिंग चार्जिंग, ड्यूरिंग डिस्चार्जिंग कंटिन्यू अलाइव है, और उसे कुछ भी फॉल्ट कोड मिलता है, बैटरी ओवर टेम्परेचर, मान लो चार्ज कर रहे हो कोई सेल चार्ज नहीं हो रहा है, तो वो आपको इमीडिएटली क्लस्टर पे इंफॉर्मेशन डाल देता है कि ये फलानी प्रॉब्लम हो रही है।
ऑल्सो जो
नहीं, बट मेरा कहना ये है कि बीसीएस हमारा ऑन रहता है उस टाइम जब चार्ज करते हैं।
बीसीएस ऑलवेज ऑन रहता है।
बीसीएस आपका ऑन रहेगा टेम्परेचर मेंटेन करने के लिए। इफ इन केस द टेम्परेचर इज नॉट मेंटेन्ड या बीसीएस नहीं ऑन हो पा रहा, बीसीएस में कोई इशू है, तो दो बीएमएस है that will limit the current. If we are doing the charging with 200 ampere and still the temperature is going up and up, so the BMS has the right to decide that we have to charge with 100 ampere or 50 ampere in that case.
Okay, yes.
Shubham, hello Shubham, Arjun this side.
Yes sir.
My only question, in the previous slide you have mentioned the
CC and CV.
Right. So just want to know what is the time limit, how much time it takes to do all the function, for example to check the IR value, to check the contractor and everything. What is the time? Just want to know whether
approximately we can go up to 1.5 minute, because as per DIN standards every time is decided that pre-charge time is limited to this time, the cable check time is limited to this time, like pre-charge 7 seconds, cable check is 30 seconds. So based on the operations the time is limited to 1 to 1.5 minutes.
That is maximum time.
Okay, it is a part of charging, including charging time, right?
Yes.
Okay, got it. And second thing that you have mentioned that while doing charging, it check the IR value up to 750. While it check the high voltage current, it send the high voltage value, right? 750 approx 700. You told me, right?
Yeah, up to 700.
So
as per charger, because the Exicom charger we have that gives up to 700 cable check voltage. The Delta charger we have that gives 400 cable check voltage. So based on that,
in this case, if there is any incident failure, okay,
yes,
when it sends 7, so what will happen? What will the issue?
It will not go to the pre-charge stage. It will stop the charging as it is.
Okay. So it means up to PDU, it will detect the failure. It will cause the failure, right?
Before the contactors, the charging contactors, it will check the insulation up to charging contactors in the PDU. So if there is any failure in the line, so it will stop the charging before going to pre-charge state.
Okay, and after 700, it start decreasing the voltage, or it start
Yeah.
remaining the same voltage?
During the cable check, it will increase the voltage up to the required voltage, like 400 or 700 as per the charger. So after the cable check, it will again go to 0 volt before
Okay,
going
0
to
volt.
the pre-charge state, because it has to build the pre-charge voltage, na? So it builds from 0 volt.
Okay, got it. Thank you for the clarification.
One query, sir. The word cell balancing, sir. So
Yes.
during charging, does cell balancing is taking place, sir?
Cell balancing is taken place after the reaching the limits. So when
How much?
almost when we reach 90 to 95 voltage percent of SOC, then the cell balancing will start in CV mode, constant voltage mode, because the battery has reached the voltage that is required. So that then it will remain constant voltage and start giving the current that is required for cell balancing. Till
Okay,
then,
sir.
So now we are
remain in constant current mode, like the 200 ampere or the 400 ampere. That is the required current, and BMS is setting
now
that
you
current.
now you can explain the CV and CC phenomena, right?
Yes.
Can you explain?
Yes.
Can you explain the phenomena while doing the cell?
Basically, when the battery is empty, almost like 580 volt or 590 volt, and the required voltage is 705 volt. Okay, so during the start of charging, the vehicle bus will send the constant current demand, like 200 ampere or the 400 ampere. Basically, my battery gives the demand up to 400 ampere. During the start of charging, if the cell voltage, if the battery voltage is very low, so till we reach the voltage of 700 volt, and like 95% of the SOC, it will go on constant current method. It will increase the voltage on and on, but the current will remain same, 200 or 400 ampere. So after attaining some voltage values that is near to the maximum voltage, so it will change to the constant voltage method. So it will set the constant voltage so that it can send limited current but variable current to balance the cell.
Okay, with adding the same question, sir. If and any case during running the vehicle or other than charging state, if cell imbalancing happened, so can we balance the cell through the charging, through connecting the charger?
Yes, if in condition during run discharging, if cell imbalance happens, we have the provision by the BMS that it will disconnect that string, so that the more unbalance will not happen in that string. So after coming to the depot, we usually charge the vehicle to and the BMS will automatically balance that vehicle.
The only condition is that cell should be in healthy condition. If it is permanently damaged, then it cannot be.
Actually, this question is raised based on the problem, actually, sir. I have faced one problem. The vehicle was running and the cell imbalancing happened. Other three strings are showing 3.6 or 3.4 something, but the one string alone is showing 4.1. So that because of that, the error also coming, the BMS error. And due to BMS error, we are unable to charge the vehicle also. So in that case, how we can resolve this issue? The vehicle is starting, vehicle is running with three string, one string is cut off. But how we can balance the cell in this condition?
Yes, that can be evaluate properly why that particular string was off. You are saying 4.1 volt cell voltage, right? So it is almost the fully charged battery, right? So why that string was off? There could be a multiple reason. The connection with the contactor. So that can be analyzed, but our bus has a capability. If one string has a problem, we can drive the bus up to depot with other string as well. So we can switch off all the battery, but it is not a good thing that the bus should remain in the highway standing there, rather than it has a capability to go to the depot on its own.
So, sir, other than BMU, other than charger, BMU also will balance the cell, right, sir?
charger is just giving information, or charging is just feeding the information or feeding the charge based on the BMS only. So BMS is the master for all the battery in any case.
Right, sir. Right, sir.
That's it.
So initially BMS only will balance the cell.
Yes,
So
yes.
is there
BMS is giving information only. What to do next?
Okay. Okay.
Kapil, my question is, if suppose vehicle get fully charged, let's say just out of our question, even though the charging is connected continuously, so will it affect the battery performance or will it not?
No, your question is not audible. Vehicle is fully charged and
Still the charger is connected. Okay. So will it affect the performance of the battery?
no, it will not take charge. That's why I said the BMS will decide the next action. He will say, I don't need charge, switch off the contactor. So my contactor will remain in switch off condition.
Okay. Got it.
If you remember in PDU, in charging, we have used 4 contactor, positive, negative. So that is also controlled by BMS as well. I am saying that is also controlled by BMS as well, because we have a CC, or you can say bus issue as well separately, which is also controlling that. So that is a complete protocol, Arjun. Matlab, I cannot define in a small presentation here right now, but that is a, how to say, SAE standard.
Okay, got it, sir. Continue.
Kapil ji, I have one doubt related to the IR value. What is the IR value we are specifying at vehicle level? Hello?
Yes, Krishna, IR, we have also prepared one separate presentation. If you allow, maybe we can flash it here. Means how the
Yes,
IR and checked.
please. Yes.
शुभम एक मेरा
Okay,
क्वेश्चन है
let prepare. So we have defined the terminology, methodology used to define the IR, how to detect the system in the IR, because IR checking is only typical process which is left in the electric buses, that which system has a IR failure. Sometime it took us as well 7 days to reach up to the root cause, like the water inside the battery. When the battery or the bus is moving at the tilted area, then only water is touching that cells, maybe the cells tip, I don't know, but that was the issue we face. So maybe Nishant can flash that page where we have defined the complete
शुभम एक इसमें मेरा क्वेश्चन था
हाँ बोलिए
हाँ मैं ये बोल रहा हूँ जैसे अपना ये जो चार्जर और व्हीकल का जो इंटीग्रेशन करने के बाद जैसे व्हीकल के साइड से डिमांड आती है किसी टाइम में इसमें वोल्टेज तो आ जाता है बट एम्पियर नहीं आता है तो इसका रीजन क्या हो सकता है इस कंडीशन में आपकी एचवी ऑन है सब कुछ ऑन है
किस कंडीशन में, क्योंकि जब चार्ज स्टेट में जाती है व्हीकल तो जो करंट और वोल्टेज डिमांड है वो पहले ही बस आपको इसको सप्लाई कर देती है चार्जर को।
चार्जर को सप्लाई कर देती है बट इन दैट केस जैसे बस की साइड से ही तुम्हारा वोल्टेज की डिमांड तो आ गई बट करंट की डिमांड नहीं आ रही है।
करंट की डिमांड नहीं आई वो ऐसे तो केस बहुत कम है, बट कंडीशन ये हो सकती है कि अगर बीएमएस ने करंट डिमांड मांगा ही नहीं है, ठीक है, उस कंडीशन पे तो चार्जर अगर आगे करंट डिमांड देगा नहीं, या
तो
कुछ एरर हो सकता है जिसको डायग्नोज करने की नीड होती है।
ओके मतलब बिकॉज ऑफ एरर, क्योंकि अगर जैसे देखा 30-40% भी एसओसी है उस केस में वोल्टेज डिमांड तो 100% आ रही है बट करंट डिमांड ही नहीं आ रही है, उसकी वजह से तुम्हारा मतलब जो चार्जर से आउटपुट ही मतलब वो भी सॉर्ट ऑफ इंटरलॉक है, जब तक मतलब वोल्टेज प्लस करंट की डिमांड नहीं आती है तब तक चार्जर की साइड से आपकी आउटपुट डिमांड नहीं है।
उसका एक और कंडीशन होता है कि आपने देखा हो करंट डिमांड तो आ जाती है चार्जर से बट ड्यू टू सम एरर जो फ्यूज होता है, फ्यूज अपना चार्जिंग लाइन का, दैट इज ब्लोन, सो जब भी फ्यूज ब्लो होगा तो वोल्टेज तो जाएगी, क्योंकि वो वोल्टेज हमारा एक्चुअली एमसीबी मेजर कर रहा है चार्जिंग कॉन्टेक्टर और फ्यूज से पहले, बट जो करंट है वो फ्लो नहीं कर पाएगी क्योंकि आपकी चार्जिंग लाइन ही कनेक्टेड नहीं है ड्यू टू ब्लोन ऑफ दैट फ्यूज।
ओके ओके।
यस
कृष्णा कृष्णा आप वो इसका सिस्टम से कनेक्ट नहीं हो पा रहा
Yes,
है
yes.
निशांत के। एक बार निशांत दोबारा कनेक्ट करोगे क्या?
Now it is audible. Yeah.
Yes, now
So
it is audible.
when we face issue like insulation failure, then there can be many cases why the insulation is failing. It is not like that actually the insulation is failed. There is many cases where LV connection is not proper. Like if we can see this page, the page A023, the insulation monitoring device page, if we are able to see the error like not operational or lost is coming, then and in this case the IMD telltale, this is the IMD telltale which will blink in this condition. At this point of time, there can be case that the connection, low voltage connection is missing. I can show you. See here inside the PDU, we can see there is a low voltage LV connector. If this LV connector is open, then this kind of fault can come that it is not operational. Then in the such case, we have to check all the connections, LV connections properly, and also all the interconnections which are coming through this LV connection. Then there can be also case of if we are seeing ground fault detected on this IMD page only, after switching on the RBC, we are seeing that the ground fault is detected and uh, IMD telltale is blinking on this condition. If we will go on the first page, main page also, it will show that the error is insulation PE, means that a ground fault is detected. After pressing the enter key, as it was explained in the initial slides, how to see the detailed error, we can see insulation monitor PE connection fault. Then this is the case of that the ground connection from the IMD connection is missing, like this. Here we can see this is the connection from to the IMD P connection. Here we can see that the connections are open. This connection is open from the stud side at the PDU. This connection is connected to the low voltage LV connector, 8-pole LV connector. It is basically connected here. If this connection is missing from this point also, then we will see the ground fault is missing. Other then we can see under voltage detected, and if the IMD telltale is glowing from means starting, it will glow, and after end it will not glow, and it will change its status from 0 to 1. Then we inside the PDU we will see that the HV connection of the IMD is missing. So these are all the cases for insulation monitoring fault detection. Thank you.
Nishant, my question is that when the telltale is coming on the cluster, that the insulation fault is coming on the cluster, there is some specification. We have designed some we have designed complete system, complete architecture over some value of IR. So what is that value?
Yeah, that value is basically if on the IMD page, if you will see the percentage, it will show around 75 or 74%, means there is actual insulation failure on the vehicle, and the minimum insulation value which we have allowed on our vehicle is 350 kilo ohm. Below that we have not allowed on our vehicle. So if such a percentage is visible on the IMD page, then we have to check the insulation of all the HV cables and all the components one by one.
Okay, okay, understood. That is 350 kilo ohm, right?
Is the lowest value.
Okay, thank you, Nishan.
Okay.
Okay, these type of detailed document for the major problem which we have faced, like IMD, BCS, TCS, we started preparing detailed document as well, which is in draft. We try to define all the scenarios, but to check, how to diagnose these type of problem. We will share with the concerns agency soon. So this is almost under freeze condition. Anything else, or maybe now we can log off, because for any question, my team is available for all the time, and you can send an email or question whenever you have. But I think the basic understanding which we try to convey to the production quality and other team members, it could be useful, right?
Yes, it is very useful. I'm very thankful to all HV team. They have given the very good presentation, and hope everybody will get some basic idea.